Oh, got it. I got it.
Okay, we are all set up. So welcome back, everybody. Can you hear me nicely, clearly? Yes? Okay, great. Let's begin. So today we'll be working on composition of function. Okay, so this is the last section from this chapter. So big concept in function, composition of function, that is how we can combine two functions, okay, to create a new function out of it. That concept is called the composition of function. So first we are going to look at the definition here. I know some of you are familiar with this concept, but for some of you this is new. So we are going to get into the detail of this. The basic definition is this: when output of one function is used as the input of another function. When output of one function is used as the input of another function. For example, down here you can see from set A to set B, we have a function g. You can see here, g is the function. Okay, so if A is the input of the first function here, if A is the input of the first function, the output is the value of the function at A, that is g of A. Okay, now what we are doing is we are making this output of the first function as the input of the other function. Now here we have the other function f. Okay, now we are plugging in g of A into f so that the final output is f of g of A. Look at that, it's f of g of A. So this is called the composition of function. So the basic definition will be when output of one function is used as the input of the other function, the combination or the entire operation, that is called the composition of function. So for any input x, now you can see here, if instead of A, if we use x, let me write there using x. So if the input of the first function is x, then what we get here is when we plug into the function g, the new value of the function will be g of x. Okay, new value of the function is g of x. Now, if you plug in this input into the function f, then the final output will be f of g of x. F of g of x. And in order to write this one, f of g of x, see, f of g of x, we can write this as FOG of x. Okay, we can write that as FOG of x, which is same as f of g of x, or sometimes we also write this as f of g, just like that. F of g, meaning it is f of g of x. Okay, so this is not the multiplication, instead this is the combination. You are plugging in function g into the function f. So that is the key there. So for input x and the function f and g, this action defines the composition FOG. And these are several different ways of writing the composition. Now, when we're talking about the new function like this, here we are talking about the composition. We must know the domain of the new function. So if you want to know the domain of the new function, there is one important thing that you should know about the function. So for the domain, what we say is the domain of the composition of function FOG of x. Remember, let me give you a little bit of a stress here on this. Let me clarify this a little more. When I say FOG of x, remember the function g is first. Okay, from first state to second, there is a function g, and then we have the function f. That's very important. And the domain will be all x such that x is in the domain of g, x value is from the domain of g, and also it is in the domain of the composition. It should be the domain of the first function, and also it should be the domain of the second function. Then only it will be in the domain of the entire function. We'll look at the example on how we can find the domain of composition at the end of the class. And then sometimes we think that FOG of x and GO of f of x, because these are composition, we are plugging in one function into other. They may be equal, but in general, they are not equal. There are only some cases where the composition will be equal. But in most cases, the composition FOG of x and GOF of x, they are not equal. So that is the basic idea about the composition of function. So finish up your writing. And in the meantime, if you have any question, you can ask me. You can unmute yourself and ask me, or you can also send question through chat. Okay, I hope you are done copying it. If you need a little bit more time, please let me know. Let me check with Prakriti. Do we need a little more time to finish up this writing?
No.
No? Okay. Okay, then let's move on to example. So here is our first question. Please copy this question now, and we are going to work on it. Okay, let's work on it now. See, two functions are given in this problem. The first function is f of x, which is 2x plus 1, a linear function. And also the second function, you can see here, it is 3 minus x, g of x equal to 3 minus x. That's also a linear function. And we are asked to find these four compositions. The first one is FOG of x. Next is GOF of x. Then f of g of negative 3. and g of f of negative 3, positive 3. So those are the questions, or those are the compositions we need to find. So let's begin with the first one here. So in the first one, we need to find f o g of x. F o g of x. So meaning of this one is into the function f. Look here, into this function f, we are plugging in g of x. Or we can write like this, into this function f. See, here is our function f. Look at the screen. Here we have the function f. In that function, you are plugging in g of x. That means wherever there is x, you are writing g of x. So this one will be 2 times, in place of x, you are plugging in g of x. So it will be 2 times g of x plus 1. Okay, so what we did is f o g of x, meaning of that is you plug in g of x into the function f. Our function is 2x plus 1. So we plug in gx in place of x. Okay, if you have any questions so far, you can ask me now. I'm going to go a little slow here because for some of you, this is a very new concept. Okay, now what we do is, see, we have 2 times g of x plus 1. Now we can clearly write the value of g of x, which is equal to, so 2 times g of x. You can see here, g of x is 3 minus x. So in place of this g of x, we can write 3 minus x. 3 minus x. And then here we have a plus 1. So we carry over that plus 1 like that. Now my final result will be, if we multiply, if we distribute this 2, you can see here 2 times 3 is a 6. And then 2 times negative x, that is a minus 2x or negative 2x. And then here we have a plus 1. So this is equal to 6 plus 1, that is a 7 minus 2x. Right? We get 7 minus 2x as the value of f o g of x. That is the composition. But if you have any question on this one, where we plug in and find the value, please ask me now. I'll be able to answer the question and make it clear to you if there is any confusion on this one. Okay, so we get 7 minus 2x as the first one. Let's look at the second one then. If you don't have question, let's go to the next one. So in the next part, you can see it's a very similar question, but what we have said here, say, if I go back to the previous screen, here I said FOG of x and GOF of x, these composition will not be equal for most of the questions, right? So maybe in this one also, FOG and GOF, they may not be equal. For FOG of x, we got 7 minus 2x. So now if I try to find GOF of x, it will not be 7 minus 2x. Okay, so let's check it. So next one is GOF of x. That composition, we need to find that composite function. Now, see, GOF of x, that is in the function g, here is the function g. In that function, in place of this x, in place of this value x, we have to plug in f of x. So it will be 3 minus f of x. It will be 3 minus f of x. Why? The reason is simple, because we are plugging in f of x into the function g, and g is 3 minus x. So 3 minus, in place of x, we are plugging in f of x. So this becomes 3 minus f of x. If you have a question, you can ask me. Okay, look like you are following through. So this is equal to, now we write the value of f of x. So we have 3 minus f of x. f of x is 2x plus 1. So let me write that 2x plus 1 here. When you are writing the big expression after the multiplication sign, make sure you write inside the parenthesis. That's very important. So that's why I put the parenthesis around 2x plus 1. Now we can simplify this. 3, if we distribute that negative sign, negative 2x minus 1. So that will be equal to, you can see, 3 minus 1, that is a 4, minus 2x. So we got 4 minus 2x for that. Hold on, it's not 4 minus 2x. Here we have a 3 and then minus 1. 3 minus 1 is 2. 2 minus 2x. Not 4 minus 2x. 2 minus 2x. 2 minus 2x. Okay. That is right, because 3 minus 1 is a 2, not 4. Okay, if you have any question on these two, you can ask me now before we move on to the third one. We did the first composition. We did the second composition. After that, we are asked to find these two. Okay, let's go to the third one. So here we have to find the composition of f and g at negative 3. So we are finding f of g of negative 3. F of g of negative 3. So now the meaning of this one is, first we have to find the value of g of negative 3. See, inside the big parenthesis, we have g of negative 3. So first we have to find what is g of negative 3. So f we copy as it is. This f we copy as it is. Now g of negative 3, look here. G of x is 3 minus x. So g of negative 3 will be 3 minus negative 3. So that will be 3 minus negative 3. So for the quantity inside the parenthesis, we use the value. G of x, you can see, g of x is 3 minus x. So g of negative 3 will be 3 minus negative 3. So whatever is there inside the parenthesis, we carry over as it is by plugging in into that function. So now, if we simplify that, look at the screen now. If we simplify this, here we have a negative and a negative 3. That will be a positive 3. So this is technically 3 plus 3, which is a 6. Which is a 6. So now it becomes f of 6. Okay. Now it becomes f of 6. And you know that f of 6 means you plug in 6 into the function f. So here is the function f. F of x is 2x plus 1. So f of 6 will be 2 times 6 plus 1. So you plug in there. It will be 2 times 6 plus 1. And that is equal to 2 times 6 is 12 plus 1 is a 13. So the value of this composition, f of g of negative 3 is positive 13. Okay, that is positive 13. So please copy that and then try the fourth one here. Please find g of f of 3. We did the third one. Now it is your turn to try the fourth one there. G of f of 3. as you're working on that, there's a question in the chat. Chandana asks, how do I know whether this 3 minus or negative 3 is a multiplication or addition? This is the operation that you know from the function. You can see the function g has subtraction in the middle. So it can be addition or subtraction, but not multiplication. Because inside the parenthesis, you are operating on function g, and function g has subtraction there. So that's what you'll do, okay? If there was multiplication, we'll do multiplication here. So we'll look at the original function for that. I hope that helps. Okay. Vidya, check your answer one more time. Chandana, you got it right. Aditi, please check your answer one more time. Also, Vidya, check your answer again. Okay, I can see some of you got the answer. Some of you are still working on it. Some of you don't want to share it. Aditi, you got it right. So let's quickly check it because there are some correct answer. Some of you are still working. So let's find out what is the right answer. And some of you have a little bit of problem in the middle in simplification. So let's quickly find out what is the correct answer. So let's work on it together. Okay, the fourth one we have here is we have to find this composition, G of F3, G of F3. So what we do is we keep this function G as it is, and then we find the value of f of 3 inside the parenthesis. Okay, we find the value of f of 3 inside the parenthesis. So f of 3 will be, we plug in 3 into the function. F of x is 2x plus 1. So f of 3 will be 2 times 3 plus 1. So inside the parenthesis, it will be 2 times 3 plus 1, which is equal to g of, now you can see 2 times 3 is a 6, 6 plus 1 is a 7. So it becomes g of 7. Up to here, most of you got it right. Now, when we say g of 7, you plug in 7 into the function g. G of x is 3 minus x, so it will be 3 minus 7. Okay, it is 3 minus 7. And 3 minus 7 is negative 4. So the correct answer must be negative 4. Okay, this is how we can find the composition of function and also evaluate the composition at finite numbers like this using the simple process of substituting the value into the function. So this is one type of problem on composition of function. But before we move on to next example, if you have any question on this one, you can ask me now. Okay, look like there is no question. So we are going to look at different type of questions in next example. So in this example, we have the information given in the form of the table, and we are asked to find those compositions. So first, copy the question. Okay, let's work on it. Look like you are done copying it. Let me check with Chandana. Are we done copying it? Give me a thumbs up if we're done. Okay, there we go. So we are done. So let's work on this. See, the information is given. First, you need to know the meaning of this table. You can see different values of x are given. Okay. And here we have the value of the function f at x equal to these values. That is f of 1 equal to 6, f of 2 equal to 8, f of 3 equal to 3, f of 4 equal to 1. Similarly, there is a second function g given here. G of 1 is a 3, g of 2 is a 5, g of 3 is a 2, and g of 4 is a 7. So that is the meaning of that table. So using that table, we need to find these values. So let's begin with the first one. The first one has f of g3. So that is equal to, you can keep that f as it is. Now see, g3, the value of the function g at 3, value of the function g at 3 is how much? Let me check with Chandana first. What is the value of the function g at 3? How much is it? Unmute yourself, please.
2.
2, that's right. So that is a 2. Thank you. Because g at 3 is this value, that is a 2. Now, f of 2 from the table, Karina, please unmute yourself and tell me, what is f of 2 from the table?
8.
8, that's right, because f of 2 is here, that's equal to 8. So that is the answer to the first one. So we look at the table and we read it to find the value. Thank you, Chandana and Karina. Let's look at the second one now, which is g of f of 3. The next one is g of f of 3, which is equal to, so we'll keep that g as it is. We'll keep that g as it is. and we look for the value of f of 3. Okay, we look for the value of f of 3. This time, Samyo, please unmute yourself, Samyo, and tell me what is f of 3. How much is f of 3 from the table, Samyo?
3.
3, that's right, because f of 3, this is f of 3, that is a 3. Thank you, Samyo. That's a 3. So now the question is changed to, you can see, g of f of 3 becomes g of 3. Now, Prakriti, unmute yourself, look at the table, and tell me what is g of 3.
G of 3 is 2.
That's right. G of 3 is this value that's equal to 2. Okay, thank you, Prakriti and Samyo, for helping out on this one. So it's just reading the table and finding the values. Let's move on to the third one here, which says f of g of 1. F of g of 1. Now let's see who can help me with this. So we keep that f as it is. Now we look for g of 1. Vidya, please unmute yourself and tell me how much is g of 1. Look at the table and tell me what is g of 1.
3.
G of 1 is 3. Very good. Yes, g of 1 is this value, which is a 3. Now we need to find f of 3. Diksha, please unmute yourself, look at the table, and tell me what is f of 3.
3.
F of 3 is also 3. Thank you so much. So the composition f of g of 1 is equal to 3. Thank you, Vidya and Diksha, for helping out on this one. Okay, so we work on these 3 together. Now, why don't you try the 4th one yourself? Please try the 4th one. And then once you're done, try to send your answer through chat. Vidya, try again. Chandana, you got it, right? Vidya got it right. Aditi, please try again. Pooja, you got it. Diksha, try again. Aditi, you got it right this time. Awesome. Diksha, try again. Sure, Pooja. Okay, let's quickly check it. Some of you got it right. Some of you are still working on it. So let's verify the answer. So here we have g of f of 4. G of f of 4. So g we copy as it is. F of 4, if you look at the table here, f of 4 is a 1. So it becomes g of 1. That's what you'll write there. And now you look at the table, g of 1 is a 3. Okay, g of 1 is a 3. So this is equal to 3. So the correct answer is 3. Okay, do you have any question on this example? Anybody have a question on it? No question on this one. Okay, that's fine. We'll move. Okay, let me see if there is anything on the chat. Okay, got it, Sagar. I got your message. Thank you. You are here, which is fine. Let's move on to next example now. So you can clearly see that what we are doing here is, as we are working on the composition of function, we are looking at different types of questions. In the first one, you can see the first problem we did, this was algebraic question on composition of function, right? We did the math, the actual math, and we got the result. In the second one, what we are doing is the information was given in the table. We use the table to answer the question. Now you'll see a different type of question in next example. And that is based on graph. So what I want you to do is copy this question, try to sketch the graph. You don't have to make it 100% accurate, but at least you must have this sketch. So please sketch the graph and make it ready. Okay, let's find out whether you are done copying it or not. This time, let me check with Vidya. Give me the thumbs up if you are done copying it. Are we almost done? No? Okay. Okay, I'm going to wait a little bit. Look like Aditi is done. Right, Aditi? Yeah, okay. But some of you are copying, so I'm going to wait a little bit. Prakriti and Vidya, almost there? Yes, Vidya is done. Yeah, Prakriti has a little bit to finish up. Okay. Look like Prakriti is making 100% accurate graph. Hi, Samyo, are we done? Give me a thumbs up if you are done, Samyo. Yes, okay. Look like most of us are done, so let's solve this one. See, using the graph, we have to find these values, these compositions using the graph. So let me work on the first one for you. It says f of g of 1. You can see here the first function or first graph is the graph of the function g of x. The first one is the graph of the function g of x. Second is the graph of the function f of x. Okay, so we'll read the graph and try to answer this one. Now, f of g of 1, first we write this f as it is, and then we look for g of 1 from the graph. So g is here, g of 1. If you want to find g of 1 from this graph, at 1, you can see at 1, that is the point on the graph. At 1, that is the point on the graph, and you want to look for the value of the function. That is, you go towards the y-axis, and you'll see that the value of the function is a 3. So that means g of 1 is a 3. So you'll write 3 for that, which is equal to, now we need f of 3. So f is the second function. So if you look at 3 is here, and go to the function, vertically go to the function. That is a point on the function corresponding to x equal to 3. Now the value of the function is the value along the y-axis. So if you look at the value of the function, that is equal to 6. Meaning of that is f of 3 is a 6. So f of 3, this one should be 6. This is equal to 6. Okay, that's how we can use the graph to answer the question. So if we know how to read the graph, it is easy to find the composition as well. So that is the first part here. I want you to try the second part yourself now. Let's try the second part. Yes, Chandana, Vidya, you got it right. Okay, look like that was quite easy for many of you. That's why you are able to do it super fast. I can see. So to verify the answer, let me write it here so that you can check it. So the question was g of f of 2, g of f of 2. So first, we need to find the value of f of 2. So function f is the second one. Here is 2. And at 2, if you want to look at the point on the graph, that is a point, and the corresponding value on the y-axis is a 5. The meaning of that is f of 2 is a 5. So for this f of 2, we'll write 5. So that is a 5. So the new question or new function here is g of 5. G is here. And if you look at 5 is there. G of 5 is the value of this function at 5. So go to the function or the graph, put a point there, and then look for the value. Okay. Look for the value. Hold on. G of 5 is this one. Yes, that's right. So now you go towards the y value, and you can see the y value is same as the previous value, which is also equal to 3. Okay. So that is equal to 3. The previous value here when at 1 is also 3. Now also we got 3. Previous final answer was 6, but this time the final answer is a 3. Okay, so that is how we can find the composition when the graph of the function is given. So always you have to look at the value. There's a question in the chat, how I got f of 3. So in the first one, here we have a f of 3. F of 3 is you look at the function f at 3. This is 3. So when you go all the way up, this is a point on the function. And look for the corresponding y value. That is a 6. So f of 3 is a 6. Okay, let's look at the last example now. If you remember, when we started the class, we talk about the domain of the composition function. So here we are going to find the domain of the composition function. So please copy this question first. Okay, in order to find the domain of the composition function like this one, what you have to do is, first you have to find the composite function, or you have to find the composition, because we'll be analyzing the intermediate steps as well. Okay, so let's see what I mean by that. Here we need to find this composition f of g of x. So let's write that and find the value of that function first. F of g of x, f o g x, is equal to, as I told you before, see, f o g of x is plugging in g of x into the function f. Everybody look at the screen now. F of x is 5 over x minus 1. So if we plug in g of x into the function, it will be 5 over g of x minus 1. So this will be 5 over g of x minus 1. That will be the first step. Now you'll see something crazy step after this one. But you can see after we plug in the first value of the function, this is my first answer. First answer is in terms of g of x. Okay, we have to look at this one also later on when we try to write the domain of the function. Now we have to finish up this simplification by writing the value of g of x. So in next step, we write f over, you know, this g of x is this one, 4 over 3x minus 2. 4 over 3x minus 2, that is your g of x, and then we have a minus 1. So we got this. We need to simplify this one. You can see this is a complex fraction. We need to simplify this. Let's see how we can simplify that. But before we simplify, are there any questions so far? Okay, look like there is no question. Look like all of you are happy so far, which is good. Now we need to simplify this. But in order to simplify this complex fraction, see in the denominator down here, there is 3x minus 2. So what we do is we take help of this denominator to simplify this complex fraction. So what we have to do is we have to multiply both denominator and numerator by that 3x minus 2. That is the technique of simplifying complex fraction. Okay, in order to simplify the complex fraction, you have to use the fraction like that. Whatever is there in the denominator, you have to pick that and multiply so that we'll be able to remove that. There is a question in the chat, how I got or why do we get gx minus 1 in the denominator here? This is the question, this one here. Who asked this question? Let me find out. Prakriti. Okay. Prakriti, see, we have f of g of x. That means we are plugging in g of x into the function f. Okay, we are plugging in g of x into the function f. F is 5 over x minus 1. So in place of this x, we write g of x. So it becomes 5 over g of x minus 1. Does that make sense? Give me a thumbs up if you get it. Okay, good, good. Thank you, Aditi, also. Okay, now we need to simplify this and get the final result. Let's see what we get. So in the numerator, if we multiply by 5, 5 times 3, here we multiply like this, is a 15x, and then 5 times negative 2, that is minus 10. And in the denominator, now you can see in the denominator, if I multiply by 3x minus 2 here, it will be 4 times 3x minus 2. And in the denominator, there is already 3x minus 2. Okay, I'm multiplying by 3x minus 2. 3x minus 2 times 4, that is 4 times 3x minus 2. There is already 3x minus 2 in the denominator. And then here, if I distribute this 3x minus 2 to that negative 1, when you multiply by negative 1, sign will change. That means this will be minus 3x plus 2. Okay, when you multiply 3x minus 2 with a negative 1, when you multiply by a negative, sign will change. That means negative 3x will be, positive 3x will be negative 3x, and then negative 2 will be positive 2. And the beauty of this one is here, you can see these two get canceled. Okay, these two get canceled and it becomes a very, very simple fraction. What it will be? See, 15x minus 10 over, here you have a 4 and here is a plus 2. That is 4 plus 2 is a 6 minus 3x in the denominator. 6 minus 3x in the denominator. So what we get here is, this is our final answer for the composition, not the domain of the function. Okay, this is the final composition. But here we get one fraction. That is very important to note. I'm highlighting here in yellow color. Yellow and yellow, little difficult to see, but I hope you can see it a little bit, right? Okay, so this is one fraction, and here we get another fraction. Why I am talking about fraction? Because we are looking for the domain, right? When you look for the domain are the values of x for which the function is well defined. Okay, so for this function to be well defined, denominator cannot be 0, because if there is 0 in the denominator, fraction will be undefined. Similarly here, denominator cannot be 0. Okay, so we'll look at the restriction. So the restrictions are, this is the restriction. Now, gx minus 1 is not equal to 0. That's one restriction. And the restriction is here. 6 minus 3x is not equal to 0. I'm going to talk about that in a minute. But before that, first let's solve this one. See, now meaning of that is gx cannot be positive 1. If I add 1 on both sides, okay, if I add 1 on both sides, gx is not equal to 1. And if you look at your gx is this one, 4 over 3x minus 2. So we write the value of gx, 4 over 3x minus 2 is not equal to 1. Now, you know that if a fraction is equal to 1, numerator and denominator are equal. But here it is not equal to 1. Meaning of that is numerator and denominator are not equal. So this implies 3x minus 2 is not equal to 4. That is the meaning of that. 3x minus 2 is not equal to 4. So now if you add 2 on both sides, you get 3x equal to 6. I should say not equal to 6. Meaning of that is x is not equal to 2. X is not equal to 2. So domain is the set of all x except 2, you can see here, because this condition and this condition are exactly the same. If you have anything before we move on, you can ask me. Checking on everyone. Okay. So now you can see domain is everything but 2. So you can write like this. If you draw a number line to represent the domain, like we used to do in the function before, we are excluding these 2. Okay, so domain is from negative infinity up to 2. And then from 2 up to infinity. Okay, look like there is no question there. Okay, then this is all for today. See, we work on the composition of function. We work on the composition of function. We learn how to find the composition of function algebraically from the table, also from the graph. And finally, we learn how to find the domain of the function. Okay, so this is the main goal for today's class. We cover a lot, but this is the fundamental concept. When you do the exercise later on, you'll be able to understand all these fundamentals. Okay, so now as we are at the end of the third unit, I want you to finish up the remaining questions from your exercise. One more time, you'll finish up the remaining questions from the exercise. I think that will be number 13, 14, and 15. Okay, if you have not completed anything in the past, you'll also finish them. So you have to complete the exercise completely. You have to solve all the questions from the exercise now if you have not finished them. Okay, that's all for now. If you are celebrating Holi today, happy Holi. Okay, that's all for now. Take care. Don't forget the attendance, by the way. Make sure you go to the home page of the course, click the link for the attendance, complete that attendance. Thank you.